Hi, this session is about bagging and random forest, and after we explain the concepts, we will see an implementation of random forest. The agenda is bagging. We'll go to Bootstrap. We'll see random forest. We'll see random forest applied to house sales. Before we go into bagging, let's first go into what is a bootstrap. A bootstrap sample is a random sample of the data taken with replacement. After a data point is selected for a subset, it is still available for selection. A bootstrap sample is the same size as a dataset. Some samples will be selected in the bootstrap sample, but others will not be selected at all. The sample which are not selected are known as out of bag samples. For a given iteration of bootstrap resampling, a model is created on the selected samples and predicted on the outer bag samples. So bagging uses M bootstrap samples, train the model on each of the M samples, the possibility of training the models in parallel, and you can average the results. In classification, it is the majority vote, and in regression, it is the averaging the results. What is a random forest? We grow a forest of n trees, grow each tree on an independent bootstrap sample from the training data. At each node, we select m variables at random from the m possible variables independently for each node, find the best split on the selected m variables, grow the trees to maximum depth, and average the results. The classification is a majority vote, and the regression is the average the results. So the difference here is that from bagging and the random forest is that at the node we are selecting m variables out of a possible number of variables that we are having, and we are finding the best split on the selected m variables. So the tuning parameters are the number of trees that we would be building, and m is the number of variables in the split. So let's see this in action with the house sales. We've intentionally taken a very simple example so it gives us very easily to get the flavor of random forest. The first line, as usual, is importing the libraries. We read the dataset house data. We do a head so as to see whether it is being read correctly or not. And then we have the features, which are the bedrooms, bathrooms, square foot living, square foot lot, floors, and zip code. We use the features as the x variable, x vector, and y is the house data price. We do a train test split, and then we use the random regressor. Then we use the random regressor model to predict the predictions, and we use the mean absolute error for the random forest model. The validation error, which is the MAE, is coming out to be 94,395. Number of trees from the model, the default is 100, and the estimator is a decision tree regressor. So this is more or less a very simple implementation of the random forest. Hope you like the lecture.